TASM सॉफ्टवेअर इन्स्टॉल झाल्यानंतर आपल्याला असा आयकॉन दिसेल. इथं लेफ्टमध्ये आहे बघा, TASM 1.4 विंडोज 7. ओके, त्यानंतर त्या आयकॉनला डबल क्लिक करायचं, विंडो ओपन होईल. सो दिस इज युअर कमांड प्रॉम्प्ट. Here we are in TASM folder. Now just type edit. So you will go to the editor window. In editor window you have to create new file. So go to file, new. So new file is created. Now at start we will use title assembler directive to your title to the program. For example, I will write program to add two 16-bit numbers. Okay, now this is the title of my title of the program, and I will use full stop. Now after that I have to start the program. For that purpose I will use, will write the all letters in small, dot model small, so dot model small is the assembler directive, dot model is the assembler directive, and small is the argument. We have seen while we learn about assembler directives that small indicates that only one code segment is sufficient for writing the program, whose size is less than or equal to 64 kilobytes, and for this program we required one data segment whose size also will be required to be less than or equal to 64 KB. For each our program almost one code segment and one data segment, both having size less than or equal to 64 KB is sufficient. That's why we have taken argument small. After that we have to start with a data segment. To start the data segment we have dot data, and we have to write name of the variable. In data segment we will store the data, whatever data we are having, that data will be stored in data segment. Now here we will write, say, number 1. Number is the name of the variable whose type is. Now we are adding 16-bit number. 16-bit nothing but words. So we will define this number 1 variable as a defined word, and we will give some value, say 1010. While typing the digits on the keyboard, use the numbers which are present above the below the function keys, not the numeric keypad at the right side of the keyboard. Use only the numbers which are present below the function keys of the keyboard. In first row आपले काय असतात, फंक्शन कीज असतात कीबोर्डवर, आणि त्याच्या खाली नंबर्स असतात, बरोबर. त्या नंबर कीज वापरायचे आहेत नंबर एंटर करताना प्रोग्राम मध्ये. 1010H. So this is one my 16-bit data. I will go to the next line. Again I will create second variable number 2, which will be of size word. So I will define it with word, and data will be say 0210 0210H. So I have defined the two numbers with values 1010H and number 2 with values 0 to 1H. Now I have to go to the code segment to write the program. So I will start the code segment with .code. To initialize the code segment, we have two basic instructions: move AX, add data, and move DS, AX. So these are the two basic instruction which will initialize the code segment. Now in code segment, what we will do, whatever variables we have defined, that will take into the registers. We know that our processor will work on registers only, so we will work on registers only. So we have to take that data into the registers. You may think that, sir, why we should not take this 1010H directly into the register? It will be possible when we will use move instruction, but that time data segment will not be used. That's why we should store the we will store our data in data segment, and from that data segment into variable, and from variable to the register. Now I will write move AX, number 1. So whatever we are written in number 1, that is 101H, that will be copied into the AX register. And next is move, say we will second number data we will take into BX register. Move BX, number 2. So that number 2 0 to 10H will be copied into the second register. Now what we will do, we will add it. We will use the instruction add AX, BX. So here content of AX and BX will be added, and result will be stored in AX register. Now we got the result. We got the result now, and we can check in the that AX register. Now suppose you want to store that result in some another variable. That variable has to be declared first. So in data segment, what we will do, in data segment I will define one variable, say whose name is, say, result. The result generated will be of size 16-bit only, so it will be defined with word size, and we don't know the current value of the result. So what we will do, we will put question mark. So question mark means current value we don't know, that's why we have put question mark. Now after adding the result here in code segment, we got the result. We will move that result to the result variable from AX register, as our current result is in the AX register. Now we will terminate the program. Move AH, 4CH, INT 21H, and end. So these are the three steps to terminate the program. Now we have written the program. first of all we will save it with the some name. Go to file menu and type save. Now give name to the it will give we have to give name to the, suppose we have given number addition of 16 bits, so we will write add 16. That name should be as small as possible, because while executing the program we have to write the program name again and again, so it should be as small as possible. So we have written add 16 and click on OK. So if you observe here at the center or top center of the screen, we have got the name add 16. Okay, now we will go to the, we will save this again and we will go to the command prompt to execute the program. Now we came to this window. Now here we will assemble the program first. So for that we have command TASM, file name add16.asm. so it will assemble our program. Click enter. So here we will it will check while assembling any error occurs. So now some error has occurred in our program. There is no warning. Next, after this the obj object files are created that has to be linked. So if you observe here at the top of the screen, you can see t-link command is performing linking. So we will type t-link, file name is add16.asm, sorry, .obj, as we are linking the object files. Some problem is there with respect to the file name. We will go to the edit window again. We will go to the file menu, open, see here, this file I have created, I have not created with .asm extension, so I have to create it with .asm extension. I will open it, I will go to this and I will save as .asm. And we will write letters in small, add16.asm. So this is created now. We will save it. We will again go to the command prompt. Now I will type TASM, file name add16.asm. So if you observe here, the errors, there is no error now. there is no warning, all messages are passed, and remaining memory is 476 kilobytes. Now we have check this for error and warning, so that if while assembling the program, if there is any error or not. Okay, now we have and object files are created. Now we have to link that object file. We have command t-link, file name is add16.obj, as t-link command will link the object files. Click enter. Now if you observe here, this is the version of TurboLink version 2.0 of Borland International, and there is no warning for us, and linking is done perfectly. Now we will execute this program with the help of command td, file name add16.exe. Why exe? Because after linking the object files, executable file is created, so that file we have to execute it with the help of command td, file name .exe. Click on enter. If you observe here, some screen like this will arrive. Now click on here OK and enlarge this window. If you observe carefully here, at the left top we have processor version 80486, which is the upward compatible version of 8086, and if you observe here, this one is the CS. CS stands for code segment register. So this is the code segment, and in which we have written the instructions. It may be possible that we have written some instruction in editor window, and that will be converted here in different format. So at which location what is data is there, that will be shown by this CS segment, code segment. Now here this one is DS, data segment. This one is DS, data segment. This one is stack segment as right bottom, and these are our registers: AX, BX, CX, DX. These are general purpose register, SIDI, index register, BPSP, base pointer, stack pointer, data segment register, data segment register, extra segment register, stack segment register, code segment register, and instruction pointer. And at the rightmost column we have flags: carry flag, zero flag, sign flag, overflow flag, parity flag, auxiliary flag, interrupt flag, and direction flag. So these are the flags. As we have to execute this program step by step, so that after each execution of each step or instruction, we can check the content of the registers and memory. So we have facility of single stepping. Stepping means after execution of single instruction, we can check the contents of memory as well as register. So here at the bottom you can see different options are available. For stepping we have F8. If we run directly, if we want to run directly, we can use F9. But if we want to do with single stepping, step by step execution, that is single stepping, we have to use F8 command of the keyboard. So I will use F8 now. See here, the program is started with blue shaded instructions. It came here. Now what instruction we have performed? We have performed BS, AX. Okay. So content of AX is 48AE. It will be copied into the DS register. If you observe here, it will be copied into the DS register. Now first first instruction is executed, move AX, 101H. So 1010H data came into AX register. See here, general purpose register, rightmost second column. Now we will execute next instruction. In next instruction, BX should get a value. So see here, after pressing F8, we got next execution of next instruction. BX will got the value 0210H, and in next instruction it should perform addition, and that result should be reflected in. Now before that, just check the flags. Flags are still not reflected. As soon as I add this, the some flags will be reflected. The result will be reflected through some flags also. Addition is performed. So result is 1220H, and that will be shown in our AX register. As we have we got the addition 1220H. We came to the termination of the program. This is the step. If you observe here, after getting the result, we have at the end of the program for termination, we have written instruction move AH, 4CH. AH is nothing but higher 8 bits of the AX register. So 4C data will be copied into that AH register. Yes, now our program is finished and it is terminated. Now click on OK. So this is how we have to execute the program. We got the result, we got the result in AX register. Click on quit. We came to the command window. Click on exit.